Hello dear students, I am Professor Anindo Dash and in today's video I will be explaining some very interesting facts in context to the preliminary quantum mechanics. So this video I have named it as Gamification of Physical Chemistry, and you can say that here I am acknowledging Mr. Robert Gilmore, one of my favorite author, and he has written a legendary book named Alice in Quantum Land. Okay. In order to understand quantum mechanics from the grassroots level, you all can go through this book written by Robert Gilmore, and the book is called Alice in Quantum Land. Okay. So some very interesting facts will be exhibited in this video. You can see once Alice was marooned to Wonderland comes to the quantum land, and she experiences some interesting, very interesting facts. Here you can see Alice encounters some very interesting entities. They're small and they all look alike, and they are all carrying an umbrella. The only difference is some are pointing their umbrella in the upward direction and some in the downward direction. So to her astonishment, Alice says, "My God, they all look alike except a few pointing their umbrella in upward and a few in downward direction." Now what were those entities? Those entities are electrons. And students, electrons are indistinguishable particles. This is the basic difference between quantum mechanics and classical mechanics. In classical mechanics, we are dealing with macro particles which are distinguishable. You can distinguish two marbles if one is colored white and another is colored black. You can distinguish them. But whenever you enter into the quantum world, you'll find microparticles and they are indistinguishable. An electron coming from a sodium atom and another coming from a potassium atom are absolutely alike. They can't be distinguished. They can't be distinguished. They all look the same. But the only difference is either some electrons are spin up particles, plus of spin, and some have spin down, they are minus of spin particles. That is the sole difference. And from here, the concept of fermions arises. What are fermions? Fermions are particles that are bounded by Fermi-Dirac statistics. And electrons are example. Electron is an example of a fermion. Okay, and it has got a lot of interesting facts which we'll study in quantum statistics, where we'll come across Fermi-Dirac statistics, we'll come across the Pauli's concepts. But to start with, you need to know the fact that electrons are absolutely indistinguishable with respect to one another, except some are spin off, plus off, and some are spin minus off. That's the sole difference. Alice was walking by and she encounters a running electron. So Alice wanted to communicate with the running electron and she requests the running electron, could you stand still for a moment? And what was the reply of the electron? Sorry Alice, there is not enough space. Now this space, what I am talking of, is not the three-dimensional space which you visualize through your naked eyes. This is a quantum mechanical space. This is a quantum mechanical space. It has got its own dimensions which cannot be visualized with our naked eyes. It can be interpreted philosophically. So in that space, the electron is not supposed to stand still. Now the beginners will consider this to be pretty ridiculous. Why the hell the electron can't stand still? Then my dear friends, you have to move on to the next slide to find the answer. When the electron attempted to slow down, what happens? It bursts. Alice is astonished. Oh my God! What is happening? OMG! The electron says, this is the best I can do. Now, why is it happening so? If you're acquainted with Heisenberg's uncertainty principle, then you can say that both momentum or velocity and position cannot be ascertained precisely at a particular moment or at a particular instance. I'm not talking about moment because moment will relate you with time. So at a particular instance, you can't ascertain both momentum and position. So when the electron attempts to slow down, then obviously what happens? Its velocity will tend to 0. Its momentum will tend to 0. And 0 is a certain value. So the uncertainty of momentum or velocity is reduced to 0. And if the uncertainty of velocity or momentum is reduced to 0, then my dear friends, the uncertainty in position will become infinite. That's what Heisenberg's uncertainty principle is all about. So if the uncertainty in position becomes infinite, then the electron will not remain a particle anymore. It will be smeared up into the entire universe and it will exhibit its wave-like nature. That's what is the explanation. So that's all, students, for this particular video. See you very soon and bye-bye.